Hello everyone and welcome to today's webinar. Our subject today is diagnostics of small commercial buildings. I do want to let everybody know that it is a 1-hour webinar, and it's our goal to kind of give you an overview and answer a lot of your questions. And it's not a total in-depth A to Z concept of how to do small commercial buildings. In fact, I'm going to kind of highlight us where some of the challenges and some of the issues are even just finding the concept. So we thought people would like to know, people are asking, who are you and what do you look like, or who's actually behind the mic when we do these webinars. You typically hear Cullen Ginge either doing other webinars or chiming in as I do these, answering questions and giving some great feedback. So Cullen is the CEO and kind of like the basic forefather of a lot of things we talk about. It'd be impossible for me to describe all of his accomplishments and still complete a webinar. So Cullen Ginge's voice will probably appear in a little bit. And my name is Joe Medosh. I am an independent trainer. I do not work directly for RetroTech, but I do a lot of the training and help provide webinars like this. Our emails are right there. If you're welcome to send us an email if you have any questions and or any feedback. Today's objectives are the non-definition of small commercial buildings, or how expansive the definition could become. What are some of the demographics? It's mostly focused on existing structures. So ASHRAE has some phenomenal documents you can download on 30% and 50% reduction of these types of structures and how to go about that. But that's mostly if you're starting out of the ground and can complete those. But mostly today is kind of like, what are we doing with existing structures? And we're not following a specific standard or protocol. It's kind of like more of an investigative approach, some of those common defects and basic diagnostic procedures on how to isolate one structure from another. All right, we do have, it's up here, we'll send it out to you and make sure you have the link. You can go to it directly, but it's simple as retrotech.com. Commercial webinar, there's obviously no space or no line between, but commercial webinar will take you to this page, and actually you can download directly what we thought were some of the most pertinent documents that you might want to refer to that kind of complement the webinar. You don't need to look at them during the webinar, but you're welcome to. So we do not have continuing education CEUs or VPI or anybody today. We're still trying to resolve that. Stephen asked about that first thing up, and we'll see if we can't create a certificate of completion or something confirming that you were here. So that does allow you to actually do multitasking while you listen to the webinar. These are some of the most common resources that I wanted to make sure I brought up. Are you familiar with some of these icons? Or most of their web pages are almost identical to their name, but the Area Association, South Face. I have several slides from South Face. I actually live in Atlanta, and this is where they come from. And it's a phenomenal, not just training organization, but they actually develop their own program on how to do residential, small commercial, and a whole neighborhood development, all with their Earthcraft program. NEB has also come out with a standard about how to do, certify people to do testing for mostly larger buildings, but it kind of comes into play with some of these will do. If you're looking for a standard that's free, the U.S. Army Corps of Engineers has a standard you could follow, and a lot of people actually make their guidelines off of theirs. ComCheck is from the DOE about how to actually confirm compliance. It's mostly new structures. And if you've not been to the Building Science Corporation website, it has the most amazing information that you'll find, with great graphics on the how-tos and how-not-tos of some of the concepts we'll talk about today. So there's kind of a non-definition. It's a non-residential. If you're dealing with the code side, it's the not the IRC, but the IBC. So it's a buildings code type of a concept. Usually they're between 1 and 2 floors. Doesn't necessarily have to be, but in general, the concepts we'll talk about are usually just a few floors. They're around 2,500 square foot or less structures. There's almost impossible to describe all the different occupancy types that could be in there. Many are a simple shell or kind of a standalone structure. And many have, although standalone may have a complex HVAC or industrial installations that are specific for what they do or what their business model is. And sometimes they are connected on multiple sides, like a strip mall or strip plaza, or maybe they only maintain the downstairs while somebody has upstairs. So it is not a single or easy group to define as the small commercial buildings that we're trying to talk about today. Most of you, I'm sure, can imagine what they are. Most of us are in these kind of complexes almost every week. Many of us are in these kind of things, maybe sitting today or where we're at right now. Here's a general reminder about energy use by sector. I borrowed this slide from Earthcraft, South-Based Earthcraft program. It's a common numbers. So you can see the commercial is around 19%. Only the industrial and transportation kind of exceed that, but in general, our commercial side and residential usually kind of run near each other. There's a lot of room for energy audits and energy improvements with these types of structures. Maybe that's why we have a large turnout today, is that the residential market is becoming saturated, and I wouldn't say by any means that it's a common household concept to have an energy audit or evaluation, but for a lot of commercial structures, it's not even thought of as to why they would consider this or do this, even though they have a huge amount to gain from these types of energy evaluations or audits. So when we compare the size of structures for commercial buildings in the U.S., these are the ones that are around 25,000 square feet or less, is almost 90% of them. So, if you're dealing with this grouping as to how we want to divide the demographics, most commercial buildings are going to fall into this fairly small square foot footprint. What becomes more complex is what's inside the box. So I kind of describe it as a building phylum, the same way we would discuss creatures in the real world as in terms of phylum or how they actually fit into an order. Commercial has is a whole different species by itself. It may have some attributes from residential. It may have some attributes from multifamily or large buildings or complex structures. So it really is not something that's always easily defined, as I pointed out. But what I really want people to focus on, if they have a few in their head or they do these regularly or maybe not, is what are the design conditions? What is the HAC system, and is ventilation as it should be in the structure? So I'm not going to touch much on ventilation. We could spend a whole day on that. But what are the significant items about your structure? What's its proximity to other possible impacts? Many times people are out there for comfort or non-energy concerns, when the reality is they probably could walk outside and walk down the street a little bit and find out that there's other commercial products that are being manufactured that may be impacting what they consider their indoor air quality. If you are looking for some really sound and phenomenal information about ventilation, I highly recommend you go to the RED site, which is the residential energydynamics.com, and they have a variety of products. Again, when you're dealing with commercial, it isn't straightforward, but they do have a variety of options, and they're constantly updating what they're doing and how that that works. I kind of built this slide around that. So are you an energy auditor or a consultant or somebody who deals on the energy side, or are you the HVAC contractor? I feel this is one of the greatest things the industry is trying to figure out as to where energy auditors or the energy stuff fits. And I'm not saying that it has to be the HVAC contractors, but our goal is that we want to be an industry just like they are standalone. I do feel strongly that when you combine these two forces together, that energy auditors go out and find a few HVAC contractors find a few energy auditors, that you kind of complete a whole package that you really kind of need when you go into many of these types of structures. And it doesn't mean more money for both of you, because you've actually opened up your business model to a much larger solving solution that's out there. So I describe it as KFC and Taco Bell and a gas station have all figured out that they can live under one roof. They all sell food and beverages, and somehow that seems to work for all of them. And by the way, that's a small commercial structure. So I think somewhere there's a fit where many of us want to stand alone or do our own thing, but I think somewhere we're trying to find a place where we fit together. One of the things I'm trying to focus on is why are you there? Doing small commercial structures is not like showing up at a residential house, being able to ask a few questions, look at their utility bills, and kind of get an idea about what's happening. You really need to spend a lot more time there and determine what their goal was. You know, is it energy bills or is it green business model? A lot of times you're there due to, you know, energy is the last thing actually on their mind. It's usually a comfort issue. And I got the image there of the person sitting by the windows. So in the summer they're kind of hot, and in the winter they're freezing because the HVAC system is working fine, but the structure was designed in a way that their body temperature was being completely determined by what they were near. You know, stains in the drop ceiling. I cannot stress enough about really asking questions and then just stop and listen to your occupants, the people that are there. And even if it's not the main person, try and ask other people in the office about what's happening. If you go to a house, I always recommend you talk to kids because they'll tell you everything. So the more information you get will actually be the most diagnostic test you can do, is the information they can tell you. Energy is also something that is the bottom line for a lot of folks, or is kind of a bonus if they're there to improve IAQ. That each CFM does actually have a considerable amount that it can be beneficial to some of the structures that they're after. And you know, everybody now is actually trying to figure out a way to save more money. All those kind of things come into play very frequently. Somebody, Glenn actually pointed out, he's getting more and more people, it sounds like, you know, commercial side of people asking about these types of inspections, and I think more and more people are becoming a little more savvy about either energy, IAQ, or their structure in general. So these are not the show up, pull out your equipment, and quick do a test. And I highly recommend you do a consultation with the owners and find out what time it is that they have their peak evaluating time. You may go to a restaurant in the morning and it's just you and the owner sitting at the place, versus when you come back at 5:30 at night, the place is full of clients, customers, cooking staff, a variety of stuff happens. So if you really want to evaluate what's happening, you really want to make sure you understand their entire business model and what their clients are doing. So, you know, a 5-minute test to do a you know, blower door test could take up to 5 hours, depending on what kind of conditions you had to work around, or whether you had to be there late at night or early in the morning, maybe even on a weekend or holiday, in order to accommodate some types of business models. And OSHA does not show up at many of the circumstances in your residential life, maybe if you live in a big city, but they do show up, and they do have a variety of issues that are a part of a commercial application. So if you're not taking an OSHA certification class, I highly recommend at least doing, there's a 5-hour, 10-hour, and a 30-hour. So those are things you could have underneath your belt that actually reduce your liability when it comes down to it. Okay, so this is not a testing standard kind of a conversation. It's if you're looking for something, the Army Corps does have a set of standards that is free. And one thing you want to remember is commercial occupancies do have something that residentials really don't have on the same scale. You can call it fresh air, but the reality is it's not that fresh. It's just makeup air that's required for the occupants. And there's many different ways that can actually come into play with a commercial structure. But they actually do have to have a system that's integrated with their HVAC handlers to accommodate that. So one of the most fundamental diagnostic tools you actually can do, and you do not have any other equipment except your manometer, is just trying to determine where the air barrier is located, zonal pressure mapping, basically. So you really want to find out is, are you actually testing the actual active environment, which means that they have a variety of exhaust fans or kitchen fans. Are they on, then off? What kind of impacts are they having? Have I figured out where the pressure boundary is, with just reference to the outside? And we recommend that you kind of go through the areas around the structure from low and high, around as many walls as you can actually kind of get access to in areas. You're going to have to put some small holes in the wall to kind of do this successfully, to find out what's happening in the room and even inside the wall itself, to find out where and what's connected to what. And once you get your zonal map, it's going to help guide you as to really what are the normal pressures that this structure might be encountering, whether it's active or non-active. And you really have a hard time doing this on an incredibly windy day. You need to be careful of your reference tube. Large temperature differences can also create a stack effect depending on temperatures inside and out, or where the structure is in relation to itself in a building. And tubes are affected. The tubing will be affected by temperature and also direct temperature from the sun and its exposure. So if you're going to be doing this, this may take you maybe a couple hours. So you know, the temperature may be changing, or the sun may be beating down on your tubing that you have referencing outside. So those kind of things could impact your testing procedures. And where is it also related to proximity to other structures? So if you're trying to isolate adjoining structures, I have some slides towards the end to kind of demonstrate how I can, with 1 or 2 fans, try to actually control this or set this up. Somebody asked about, I kind of glanced up at the questions, OSHA certification for what? OSHA has basically it's a general safety class that they have that makes sure that you're, proceeding in a structure or in a kind of a testing environment and using safe practices, to kind of go back to one of the questions. So you may have structures that are only connected on one side or two, or you're trying to even isolate sometimes an environment inside the actual structure itself. So you also are trying to figure out some other complexes that have adjoining or combined walls. Many places sometimes even have combined ceilings, even though they're actually a separate type of structure. One of the ones that's most common is a strip plaza or strip mall, where you have 3, 5, 10, sometimes as many as 20 different occupancies inside of that. So one of the ones that's a kind of most common issue that happens in these types of structures, and what I'll do is I'm going to go to the next slide. I'll come right back to it. Oops. Is they kind of look like these are some of the strip malls or strip plazas that I'm referring to, that have this walkway or overhang that actually happens, that's outside, but ultimately can sometimes be brought inside to the structure. So the picture in the upper right, I have a bigger one on the next slide, but it's showing outside through the window, and the bottom one is a part of the Building Science Corporation, showing how you can actually have infiltration that happens inside the walls that also gets brought into the structure. The illustration that I have now is referring to drop ceilings that are used as a plenum, and the plenum is where all the return air is kind of being brought back. So you can think of this whole drop ceiling up in green as an area where all of the return air just kind of gets brought up on the other side of the drop ceiling, moves around anywhere, and finds its way back to the return path. It's conditioned and is brought back into the structure with the white ducts here. And it's brought back in and returned. So there's no actual return duct system in this illustration. Most commercial structures are moving away from that, but as you saw the illustration or the numbers earlier, there's a huge amount of structures that are existing that kind of complete or may fit this model. I bet as you drive anywhere today, you'll drive past maybe 1 or 2 of these types of structures. So the issue that happens here is that when I have this air that's just kind of running wild up on the upper section, it's exposed to areas that become outside or outside walls or outside ceilings that are part of the walkway. So I could easily have, with can lights or other penetrations, hot moist air that comes into these sections. It's now mixed with the conditioned air that I have, if I have any kind of like water pipes or the ductwork itself that can actually have a temperature change. Now I have a dew point or condensation issues, and ultimately that could lead to stains on the ceiling. So I've actually talked to a couple of people. We did a presentation like this many months ago, and they're like, yeah, after I saw your thing, I cannot go into a doctor's office or, you know, get my hair cut, and I look up and I see stains, and now you understand what's happening, that it isn't necessarily a roof leak. Chances are it's a condensation issue, and they have air infiltration issues. So if you go into one of those places, it's the perfect time to open up a conversation about what's causing that, what are those issues, and of course it's the building owner's problem, but as they know as a tenant, that these are also issues that do affect their business model. Oh, Andrew points out that it's called a free vent area. There's a variety of terms that I appreciate your feedback, Andrew. So this is one of the most common defects that I felt was out there when we talked about these kind of structures that drop ceiling, and it's not a misspelled title there. It's that many of them become droop ceilings, or they just have a lot of issues that are above it, or poorly installed, poorly maintained. Many of them have insulation that's up there and may or not be a free vent or an open plenum kind of a concept. As well as many of them are also exposed to cold surfaces like the back of the wall or joining walls, and that's also causing them issues. There could be an entire week-long or at least day-long course about HVAC systems, and I try to make the V either disappear or make it small, because many of those have a ventilation that's incorporated in it, but if you're going to these kinds of sites, or this is one of the things you want to add to your business model, it's crucial that you understand how their HVAC system is working. Many of them are simple residential systems like strip malls or strip plaza. Each individual place usually just has something that's a real simple concept or a setup that's not too difficult to understand, but many of them have various things that are more complicated than what I would ever really want to diagnose without having a professional there on site with me to help conclude what are the effects or what's not actually performing correctly. Many of these structures also have full-blown super refrigerant systems that also are a major impact on their energy load or even their comfort. And again, something that's beyond my ability to inspect or diagnose. So I try and find out what it is they have, and I would have somebody with me that specializes in that there at the same time, so we're on the same page talking about the same issues, and I usually get a learning curve out of it. So an economizer, just to make it brief, is actually something that can help control the temperature of the air that's provided, as well as create the makeup air that's all part of the occupants. So it is a damper that actually will determine how much gets brought in or not brought in for the air that gets, that's the makeup air, and also controls the temperature. That's the simplest way I can kind of describe that. So it's a series of dampers. So again, these kind of things can be a challenge to evaluate or determine, or if you're going to evaluate duct leakage, I definitely want to encourage you to have somebody that's HVAC savvy when you're dealing with some of these larger types of rooftop units. So we do have a link on that, the link that I had earlier. It does have an Excel spreadsheet that tells you how many fans that I might need and how to diagnose that. We're also trying to improve that. One of the things that comes out in here is square footage versus surface area versus volume. So in general, a lot of the folks deal with commercial are usually dealing with actually a surface area, and it can range from 0.4 to 0.25, and I should have there, apologize, CFM per square foot of the surface area. So that helps me determine what my leakage may be, and most structures are maybe even leakier. That'll determine how many fans I might need once I understand the surface area of the structure. The surface area does include the ceiling or the roof and also the floor or the concrete slab. So it is all 6 sides that you're trying to create as a surface area to calculate what that is. There are other compliances. California has an SLA, which is based upon square footage. So you have a variety of options that you're trying to evaluate if you're using a standard practice or just want to compare it to a general application. So you can do volume, and then you're also just kind of comparing later what your volume is. So here's the calculator that Retrotech has. It's an Excel spreadsheet that gives you some guidance on what's your goals in terms of leakage and what's your surface area for square footage. And it's a real step-by-step process with instructions that explains how that kind of works. A lot of people are looking for some general rules of thumb because these sometimes do not actually come out to be straightforward structures. So if it's on or operated all the time, like for instance if you're in the kitchen environment and they actually have their fan, it's almost running all the time, it's a ventilation fan, so it's not something that really turn off at all, then you do not cover it and it's left off, but I've left it open. All right. Or if it's something that's turned on or off and used intermittently, like a bathroom fan maybe, or something that has not something that's constantly on for the majority of their operation time, then I actually will turn it off, and I can also cover the opening. These are not hard and fast rules, but they are something to kind of give you a concept that, in general, this is how I want to think about the operation of this structure and how I want to test it if I'm going to do some kind of a blower door or envelope leakage concept. Colin, do you want to chime in on how you conclude these or how these become your applications?
Sorry, Joe, I was a bit zoned out there.
No
I
problem.
wasn't quite sure what you were.
Yeah, it's your second webinar today, I know that. So these general rules that I have up on the slide are from you, so I was wondering if you also could share some information as to how you kind of came to these.
Well, there's 2 reasons why we would test. One is to test the, I guess, performance of the air barrier. And in cases like that, we want to cover up all the intentional openings and seal all the exhaust fans and so on, so we can measure the air barrier. The other reason why we would test would be to test the building in its normal condition to see how it's going to respond to its environment. And there, we're more interested in how the building performs, and those are the values that we would use in any energy analysis program. So my thought is that if we have an exhaust fan that's running most of the time, we would call it a device that supplies flow, and that would be entered into the calculations as a device that is causing flow to either pull air into the building or blow air out. If it was an intermittent fan, like a bathroom fan that might be only used 5% of the time, it's essentially most of its life exists as a hole, and it's just a hole in the building that causes air to flow in and out most of the time, so it's actually an air leakage hole that will affect the performance of the building. In that case, if we're interested in performance, we would leave that uncovered and test it in that fashion. Was that what you were looking for, Joe?
Yeah, that's right. Okay, it contradicts the slide somewhat, but in general, that you explained what your theory was and how you did that. Yeah, thanks. And Dan just said you just answered my question. So one of the questions I got a few seconds ago was about drop ceilings and air barrier. And in general, it's a misperception that the drop ceiling would be thought of as an air barrier, even though they do put insulation on drop ceilings, which almost makes it ineffective in general. So if you're really trying to do the volume, it really should be what's above the drop ceiling. Maybe you have a drywall ceiling and it's still an additional roof, but in general, the roof is your actual air barrier for many of these cases, and that's where the insulation belongs. So if it's not, you're going to find that they've actually kind of really challenged where the air barrier is and the thermal envelope, and they really should be in line with each other. So there's a variety of options you have for obviously finding leaks. Many of these are common for most people, but There are ways to pressurize the structure when you also can add smoke and watch and find out where it's leaking. There's the various smoke puffers that are out there and a variety of ones now are the non-toxic type. But I don't think enough can be said for the infrared thermal scan to help trying to find where you actually have air leakage versus potential moisture issues or just missing insulation for thermal bridging. Phil Emery out of Washington State let me use this slide he's got that kind of really defines exactly a few issues that are happening. If you start from the right where the numbers are, that I can actually just see thermal bridging from the where I do have insulation in the white section or the studs, so I actually have the thermal bridge right there. And in the middle, insulation was not installed in a large chunk, and there is a blower door happening right now, so you kind of can see some wind effect or air movement on that area. And on the left, they did actually install the insulation, but the blue section is showing me where I actually have air infiltration that's moving across the bottom and up near the actual framing itself. So you get a lot of effects when you combine your infrared and the blower door together, and you don't have to have such a large scale difference of temperatures in order to be an effective evaluation. One of the things that we've also, the Retrotech also sells is a new device called the Flow Finder, which is a powered flow hood, which also is a great device. I usually turn this back over to Colin. Colin, do you want to describe your Flow Finder real quick?
The Flow Finder is made in Europe. It's a product of about 6 or 7 years of development, and I don't think there is nothing like it over here. It's a very finely tuned instrument from a very old instrument company. Retrotech is providing some of the components in order to keep the price down. But this device, you can hardly tell from this picture here, but this device, including batteries and the whole flow system, only weighs 5.5 pounds, so you can literally hold it in one hand. The end fitting is 8.5 inches square with rounded off corners, and it's about, I think it's about 9, 10 inches, 10.5 inches long. So this is an ideal device for measuring exhaust fans, kitchen stoves, range tops, and so on. They're notoriously hard to get at, and even if there's relatively big gaps that you can stick your hand around, because it has zero pressure sensing that goes right down to 1/100th of a Pascal, you can actually have some pretty big gaps around it and still get a very accurate reading. It's kind of uncanny how well it works and takes a reading in about 10 seconds. So it's a device that we're getting in the hands of various trainers, and we've sold a number of them to people that are using them to measure HRVs, and I think it's one of the best in-home diagnostic tools that you could use, and it will do zero balance up to 323 CFM and compensated flow up to 500 CFM, and goes all the way down to, I think, 4 or 5 CFM. So it's a nice piece of equipment, and we think that it will prove itself to being an amazing tool out there. It's kind of like, I look at it as being an MRI. You know, before we had MRIs, we just kind of had the doctor poke and thump, and then when you have an MRI, you can really get in there and find out exactly what's going on. And I look at it as being a tool that's in the same ilk and will have as much impact on our industry as infrared has, and in the case of airflow, probably even more. So that's all I have to say. So we have them in stock, and if anybody wants one, let us know. Incidentally, we have a flow hood that's 16 by 16. The one shown in the picture there is a 9.5 by 9.5, which can be used on exhaust, which is the real tough flow to measure, is exhaust. You can easily be out with a passive flow hood 40%, no problem at all. This will measure exhaust flows, or I should say supply flows, accurately within 3%. Anyway, I'm done.
Okay, yeah, sure. Yeah, I've actually had this in my house and tested it briefly before I had to ship it back, and I'm hoping to get another one back so I can experiment with it before. But it's a if you're used to working with you know, really well-engineered tools, you know, we associate many of them with being a German engineered or you know, really fine fine woodworking equipment or something similar, this actually competes with that in an enormous way. It's I was stunned on how lightweight it was, how easy it was to use, and how fast it actually was able to determine what was coming out of the supply in my ducts or figuring out what was happening with my exhaust fans. So one of the things I was going to do now is kind of step through the process of, you know, if I have a large structure, whether it is a, you know, garage, freestanding, you know, single unit type of a kitchen, there's less things that are complicated about testing when it's versus having things attached to another structure. You know, there are a variety of issues, like I pointed out, as to what you're going to cover or not cover or have open or run or operate at the same time. And in general, most things are going to be shut down. And there is no, you know, there are standards, but most of them are not as advanced about to tell you about, if you're going to do a restaurant and it has this type of installation, then you do A, B, and C. A lot of times they're just really looking for you to apply, you know, a great knowledge to the circumstances, document it, and make it repeatable. So if you come back, it's easy to repeat, or somebody else can come back and repeat your standards. But if you do have a structure that's actually connected to another one, this kind of applies in the same way that you may do a multifamily or a combination. So I could be dealing with a structure that's only on the second floor, even though it's maybe on the third floor. Or on the right, you could think of it as a combination of, maybe this is a strip mall where I actually have a single unit and I actually have other units that are attached next door. So as I'm testing this, it's an easy way to actually pressurize the area and get my CFM reading. All right. I do want to make sure that any attached areas on the right, left, above, and below, I'm actually trying to figure out the best I can to kind of control that environment. You know, making sure that they have some type of door or window open, so there is some pathway for the air to leak out of their unit, so I can confirm that there was a total leakage. Make sure they didn't have their HVAC system on next door, or again above or below. The best I can do to control those other areas provide me with a much more accurate test. If I can actually use those adjoining areas with an additional blower door, now I can actually make some conclusions as to where's my leakage directly from my unit to outside, or how much am I leaking to adjacent units. So when I just did the single unit that I have, it was leaking 1200 CFM based upon this single blower door test. Right? If it has an enclosed hallway or a place that may be adjoining it, maybe it's an office upstairs, and you're testing it, then I can actually isolate the common wall to the hallway by pressurizing it, making sure the opposite side is sealed. And now I've eliminated the common wall, basically creating a neutral pressure zone across here. And now I actually found out that my CFM went down to 1100. So I now know that I had 100 CFM that was moving across this wall that I now just neutralized. And I can either open doors if that actually has an application, or I can actually set up another fan in there. And now I start creating a neutral pressure between, again, my main environment and the ones that are adjoining it. And I can start seeing my CFM drop, and I can now determine that also between these two units, I now have 100 CFM that's connected. And as I continue to the other side, the same thing happens. So this one's only had 50, so my larger connections were across the front or across the right side as you face the front. Oops, sorry. You can also do it on the same where you're above and below. It is difficult to also do this where you just have control over it with two fans may work in this environment. Sometimes I may be doing each one individually and kind of doing a subtraction method. But my goal is to try and find out where are my large connections between adjacent structures. If I did a strip plaza, this obviously is going to be open. There's no way to actually pressurize here. But one of the things I can do is try and determine how much of a connection I have between the neighbors. What this allows you to do, is also meet the neighbors, and you're going to find out many of them have the same potential issue or concern as your client, and now you've actually increased your business model because many people next door have the same type of energy, IAQ, or moisture problems that they do, and now you're actually going to actually diagnose most of this complex because everybody wants to have this solved. What you want to make sure is it a building issue or a tenant issue, as you keep this in mind, is that who's actually going to make the corrections or at least take care of your bill before you showed up. If they were on an upstairs, downstairs, you would do the same kind of a concept of pressurizing here, then going downstairs and pressurizing the unit below. Same thing as I would do next to it. So in theory, there would be one on the right, left, potentially above and below, all trying to subtract the CFM so I could isolate where I found my greatest leaks or issues were based upon multiple tests. And if I don't have access to these things, then it's the best I could do is at least try to make sure I could create an opening for a pathway for the pressure to release itself and make sure they were not actually having their HVAC system on or creating pressures that challenged my setup. A variety of ways that Retrotech offers to do this is fantastic, and I believe on Thursday, there is actually a fantastic, this Thursday, 2 days from now, day after tomorrow, is a webinar dealing specifically on fantastic, on how to use it, how to go through it, whether you have it and want to use it, be more efficient with it, or if it's something you actually want to learn more about and use the free version or upgrade to one of the multi-fan systems. The other way you can also document or keep track of some of the work you have is you can use your DM32, the new wireless gauge or wired gauge, or for those of you that were out there that still have the DM2, this data logger is free to download from the Retrotech website. And it will actually hook up to your DM2 with a USB cable, or the DM32 can also be done wirelessly. And what it does is it will log the data that you're actually encountering. So if you're trying to figure out some diagnostic circumstances with opening and closing vents, opening and closing other doors, or trying to make connections to adjacent units, or trying to see what's happening with your readings, you can actually log a lot of data and keep track of it as you go through the structure with a time interval, and then come back and evaluate what was happening. I can do as low as 1 second or up to 1 minute or 5 minutes, depending on my goals or objectives. This test I'm going to show you, I actually ran a test with a DM32 and a DM2 together. They logged both of these manometers, and I did it for 1 second. So I hit start logging. It kept track of the data. I hit stop logging, and it creates a great Excel spreadsheet that I can now evaluate. And because it's hard to read, I'll zoom in for you. So on channel A, it's telling me what gauge I had. And you can see that it's giving me the DM32 and the DM2 together as the readings go. So they keep actually repeating themselves every second. It tells me what the serial number was for the gauge. And here's the device. So for the DM32, I had it set up with a Minneapolis blower door, a Model 3, and the DM2 was running a Retrotech 1000 blower door. So I had 2 blower doors running. They both run the B range, and it also gives me the pressure on channel A and B as I was reading those. And for the Retrotech gauges, it also can calculate a result while it's actually doing its test, whether it's CFM or air changes per hour or SLA, whatever that is. I can actually try and calculate that and get those results right here. These are about every second apart or something. It keeps data logging it. So now I can actually go back and evaluate what was happening as I did that test. I can also share the results with somebody else, but it is a great way to document that. So anyway, everybody, thanks for joining us, and don't hesitate to register for other webinars. And at any time, you can send us an email to sales@retrotech.com or marketing@retrotech.com. We always appreciate your feedback. Thanks, everybody. Have a great day.